As I mentioned, we are going to be reviewing. This is the review for the test that we're having tomorrow. We'll be working on just the even numbers. Then you'll go back and finish up the odds. So, number one, you'll come back and do that one if you haven't done it already. We're looking at number 2. Let's take a look at number 2. Number 2, they've given me a set of points, set of ordered pairs, and the first thing they want me to do is plot each of these points. So that should be fairly easy. First thing we're going to do is find 0, 5. Let's find 0, 5. Wherever it is, let's put a dot. There it is, 0, 5. Now I'm looking for 2, negative 5. So let me find 2, negative 5, which is this point right here. Now I'm looking for 2, positive 5, which is up here. Then I want to find 4, negative 5. That's this point.
And then 4, 5.
And then 4, positive 5. That's this point right here. First part, piece of cake. All we're doing is plotting the points. Once you have those points plotted, now we can answer some of the other questions, like what is the domain? Domain. First of all, domain are the x values. So if we look here, there's some x values. We got a 0, a 2. Notice that 2 repeats again. We got a 4. Got another 4 that repeats itself. We don't have to repeat ourselves when we're writing the domain. So we've got 0, 2, and 4. So those are the numbers I'm looking for you to write down. If you didn't do that already, go ahead and do that. Now what I want to do is identify the range, the y values.
Yeah, nothing but 5.
That's right. Notice I got 5 and I've got a negative 5. Those are the only 2 numbers, and those numbers repeat a couple of times. But I only want those 2 numbers, so 5 and negative 5. Notice the brackets that I'm using, guys. Notice I'm not using parentheses. Here's why I'm not using parentheses. If I write it like this, what does it look like now?
An ordered pair.
An ordered pair. And that's not what we're talking about here. So make sure when you write these, we use the little brackets and not the parentheses. All right, number 2, next part here says, is it a function? No. Why not? Why is it not a function? X is repeat. All right, so no, it's not a function, and that's because the x is repeat. Make sure you do that explaining. No, because the x is repeat. And the last one there, they want to know, is it continuous or discrete? For those of you that don't remember, discrete means when the dots are not connected. Continuous means that the dots are connected.
Discrete.
And of course, this one is discrete. And why are we going to call it discrete? That's right. Points are not connected. And remember, guys, if it says explain, make sure you're doing the explain. All you do is put yes or no, and I'm going to make sure I count it wrong. Got to give me the explanation. All right, so that's number 2. When you go back and do number 1 for me, it's going to be pretty much the same thing. Number 1 and number 2 are pretty much the same. So let's go to the next one. Number 3, you're going to work on that one for me. We're going to take a look at number 4. Number 4, I'm given a graph. And from this graph, I've got to answer a couple of questions. So the first question I've got is, what is the domain? They want to know, what are the x values on this graph? Well, there's a lot of them. And if I try and write down each and every x value individually, it's going to take me forever. Well, what am I going to write down for my domain? Well, notice here I've got an x value here. Here's an x value. I got an x value here, here, here. What do little arrows mean anyway? What is that little arrow right? It keeps going. So this graph is going to keep going out in this direction, and it's going to keep going out in that direction. So really what we want to say is we want all the positive x values. So isn't that what we have here on this graph? Everything on this graph, notice how the x's are positive numbers. So that's what I want to say when I write my domain. So here's how we're going to do it. We're going to say that the x's have to be numbers that are greater than or equal to a 0. So we're just saying all the positive numbers. That's what we're saying. The range, the y values, we're looking at the y values now. Notice how the y values, we got 2 types of numbers. We got positive numbers, that's this part up here. These are positive y values. And then we got some negative y values. So basically what I want to say is I want all the numbers. Does anybody remember how we can write all the numbers? Positive and negative. All real numbers. Okay, so the answer I'm looking for here is all real numbers. Now, you can use shorthand here and use this symbol to represent all real numbers. If you're too lazy and you don't want to write out all real numbers, you can use this symbol right here. All real numbers. Third part of that is to identify whether it's continuous or discrete. Continuous, that is correct. And why are we going to call this continuous? The points connect. That's right. Points are connected. We also said a continuous graph is either a line or some kind of smooth curve. Next one says, is it a function? No. Is it a function? No. No. This is not a function. Why is this not a function? X is 3 repeats. Now, just a little reminder, guys. You can tell that the x's are repeating on this graph using something called the vertical line test. And the way the vertical line test works is if I run a vertical line across my graph here, notice how many times this vertical line is going to touch the graph. Notice that it touches the graph once here, and then another time over here. And because it touches twice, basically what's happening here is we're using the same x value. We got the same x value that we have here and here. We got x's that are repeating. So you can also use your vertical line test. The last one there says, if it is a function, tell the intervals where it increases or decreases. Well, did we say it was a function? No. No. So am I going to answer that question? No. No. There's no need to because it only says if it is a function. And it's not. So don't worry about answering that question. Okay, we're going to skip number 5. You'll be working on that one for me. Let's take a look at number 6. We're looking at number 6. Number 6, what they've given me is an equation. This is the equation I'm working with. Y is equal to 12 divided by x. We're going to do a couple of things here. We're going to first create a table. Once we have the table, we'll go ahead and graph it. And then we'll answer these 4 questions down at the bottom. So let's go ahead and figure out what this table is. First thing I need to do is figure out what 12 divided by negative 6 is. If I plug in negative 6 for x, 12 divided by negative 6 would be a negative 2. Put that in your table. Now I need to know what is 12 divided by a negative 4. Negative 3. Now I need to know what is 12 divided by negative 3. 4. 12 divided by negative 2 would be a negative 6. 12 divided by 0 is error. Now just real quick here, guys. Why would you get an error here? Can you divide by 0? No. No. This is why the calculator gives you an error. You cannot divide by 0. Let's keep going here. 12 divided by 2, 6. 12 divided by 3 is 4. 12 divided by 4 is 3. And finally, 12 divided by 6 is 2. Now, one thing you guys need to keep in mind is this table that they gave me, are those the only x values that we can use? No. Now, remember, I could have also used 8, 10, 12, 13, 14. These are just some numbers that they gave me. They're not all. So just keep that in mind, because that's going to come in handy in a little bit. All right, so now that we've got the ordered pairs, now let's go ahead and graph this. First order pair we have is negative 6, negative 2. So let's come over here and find negative 6, negative 2. Now I want to find negative 4, negative 3. Let's find negative 4, negative 3. Negative 3, negative 4. Negative 2, negative 6. 0 error. How do you graph 0 error? You don't. So skip over that. It's like a big hole in our graph. Next one is 2, positive 6. So let's find 2, positive 6. Then we're looking for 3, 4. 6, 4, 3. And 6, 2. here's what I have. Now, in this particular case, guys, I'm going to go ahead and connect these dots. Because remember, we just got through saying these are not the only x values that we can plug in. I could have also plugged in 8, 10, 12, 14. So I'm going to show that by connecting the dots. Yes, go ahead and connect. Now, what I'm not going to do is I'm not going to connect this bottom part with this top part up here. And that's because we had that zero error. Like that big hole in the graph that I was talking about. So this is the graph we end up. So now that I have that graph, let's answer some questions. First question is identify the domain and the range. Tell me the x's and the y's. So let's start with domain, the x values. What kind of x values do we have on this graph here? Okay, but are those the only ones? Almost all real numbers. But there's one number that we don't want to include in that set. Zero. Why don't we want the zero? Because that error. So we want to say all real numbers except for zero. So here it is. Here's the notation for all real numbers. But I want to leave out the zero. So what I'm going to do is I'm going to say the x cannot be zero.
Is that a D?
Yeah, D for domain. The domain is all real numbers. The only number I'm not going to use is zero. That's domain. Now let's talk about the range, the y values. The y value is pretty similar to the domain. The y values, we want all of them except for one number. What's the number I'm not going to use on the y here? Nope. Zero. Notice my y values are everything above the x-axis and everything below the x-axis. The only thing I'm not including is the x-axis itself. So here it is. Again, same thing, all real numbers. The only y value I'm not going to use is 0. Those are the only x and y values I'm not going to use. 0. Next question wants us to identify intervals where the function increases or decreases. So let's take a look at this graph here. Notice there's two parts. Let's take a look at this part down here in the third quadrant. What is it doing? Is it increasing or is it decreasing? Is it going up or is it going down?
Going up.
Going up. No, I'm looking at just this part right here in the bottom left. What is that? It's what? Decreasing. Notice it's going down. When we start at the left and go to the right, this thing is going down. What about this one over here in the first quadrant? What is it doing? It's the same thing, guys. It's going down. If I start from the left, go to the right, notice that it's going down. So both parts here are going down. Both of them are decreasing. Okay. What we want to do is identify the intervals where it does that. So here it is. First of all, let's say that it is decreasing. That's all we have in this graph is decreasing. So let me talk about this third quadrant over here. It's decreasing where the x values are less than 0. In other words, where the x values are negative. But it's also decreasing where the x values are greater than 0. In other words, those positive x values. So it's decreasing in both of these places, where the x's are negative and where the x's are positive. This is an interval where it decreases. This graph only goes down, it does not go up. Okay, next question wants to know, is it continuous or is it discrete? Continuous or discrete? Continuous. Why are we going to call this continuous? The points are connected. So let's do that. Continuous, and that's because the points are connected. Points are connected. And the last thing they want me to do there is identify the parent function. Remember we talked about the parent functions that first week? We had linear, we had quadratic, we had absolute value, all those parent functions that we've discussed. Which one does this look like? Which one has the two parts? Rational. So this is what we're going to call rational. Rational function. That's because it has those two parts.
I need Mandy Gonzalez to the nurse's office, please.
Okay, let's take a look at number 8 and number 10. Yes. Number 8 and number 10, we're using that function notation. Notice that we've got two different functions here. We've got f of x, and we also have g of x. So we need to make sure we're using the correct function for each of these. Notice that 7 and 8 have an f, which means you should be using this function here. 8 and 10 have g in it, so we should be using this function right here. So the ones we're going to be working on, we're going to be using g of x is equal to x squared plus x minus 2. So here we go. We're going to start by finding g of negative 2. And the way we're going to do that is simply by replacing each of these x's right here with a negative 2. Let's do that. Here's the negative 2. Here's another negative 2. Now at this point, so we don't make any mistakes here, all we're going to do is type it in the calculator exactly like you see, with the parentheses and everything. Notice how my negative 2 is in parentheses. The square is on the outside. Nope. No. Everybody put that in your calculator. Let's see what we get here. Remember, use the parentheses. And what do we get? 8. That's not what I'm getting. What? 0. 0 is what we should be getting. Again, make sure you're using parentheses. Make sure the 2, the little square there, is on the outside of the parentheses. Otherwise, you will get the wrong answer, guys. All right, so we should have 0. However, we need to make sure we use the correct notation. The notation we're going to use is g of negative 2 is equal to a 0. That's the notation. As a matter of fact, there was another way I said you could write the answer. Does anyone remember the other way? That right there. What is that called? Ordered pair. Ordered pair. So you can write your answer either way. Use either the function notation or use the ordered pair. But don't just give me 0. All right, next one's going to be a little trickier here. What they want me to do is find g of a minus 1. So just like number 8, we're going to start off by replacing each of these x's again with an a minus 1. All right, so all I did was replace the x's with a minus 1. Now, unfortunately, I can't just throw this in the calculator and the calculator give me the answer. That's because I've got some variables there. So we're going to have to do a little work. I'm going to do a little scratch work out to the side. I'm going to take that a minus 1 and I'm going to square it. Because all that means is multiply it by itself. So here we go. A minus 1 times a minus 1. First, I've got to multiply a times a, which is going to give me a squared. Then I've got to multiply a times a negative 1, which is a negative 1a. Then I've got to multiply negative 1 times a, which is a negative 1a. And then finally, I've got to multiply negative 1 times a negative 1, which is a positive 1. Now notice how the two terms in the middle, they are considered like terms, which means we can combine them. And if I combine those two together, what I'm going to end up with is a negative 2a. So when it's all said and done, when I square that a minus 1, this is what I get right here. So let me come back over here and put it in. A squared minus 2a plus 1. So I've got that. I'm going to add it with this, and then I'm going to subtract this. Now keep in mind, when you add and subtract, you can only add and subtract terms that are alike. So when I add over here, this a squared, I can only add it with another a squared. But do you see another a squared in the problem? No. So let's leave that one alone. Don't touch it. Now I'm looking at the a's. I've got this negative 2a. What I'm going to do is add it with this a over here. So what's the negative 2a plus a? Negative 1. Negative 1a. Now what I have are these terms right here called constants. I need to combine those. So let me start right here. This one plus this negative one. What's 1 plus a negative 1? 0. I'm going to take that 0 and I'm going to subtract 2. So 0 minus 2 would be a negative 2. So at this point I've got a squared minus a minus 2. Notice there are no like terms anymore, which means I'm done. Let me just go back and use the correct notation. And there it is. So g of a minus 1 is going to equal to a squared minus 1a minus 2. By the way, remember, we can use or write it as an ordered pair as well. The ordered pair would be a minus 1, that's our x. A squared minus 1a minus 2 would be our y value. So you could also write the answer like this here. But make sure you do use the correct notation. Any questions on 8 or 10? In a minute, you'll go back and use do number 7 and 9. All you're doing is taking out the x in this function here and replacing it with a 4 and a 3/5. Just make sure you use your calculator so you don't make any mistakes. 11, you'll go back and work on that one on your own. Let's take a look at number 12. On number 12, the following data compares the mean height of children in relation to their age. What we want to do is we want to plot the data and then answer some questions about that. So what I need you guys to do is go ahead and take each of these ordered pairs and put it on your graph paper form. So if you haven't done that already, I need you to do that right now. Just take each ordered pair and plot it on your graph paper. I'll give you a minute here so we can take a look at your graph. All right, looks like most of you are through or just about through. The graph you're getting should look something like this right here. So the same kind of graph you're getting, it looks like that. All right, so let's take a look here at the questions they've given us. The first one wants to know, is the relation a function? What do you think? Can I call this a function? Yes. Yes. Why can we call this a function? Because the x's don't repeat. Very good. So yes, this is a function because the x's don't repeat. Or in our case, if we're talking about age in month and the height, each age in month has its own specific height, and the age in month does not repeat. You're only 18 months once, right? Let's see here. The next one. If it is a function, which we said it is, if it is a function, identify increasing or decreasing intervals. So look at your graph, guys. Look at your graph. Would you say that this is increasing, decreasing, or would you say both things are happening? It's increasing. Do you see any decrease in the graph? No. So right here what we have is increasing, and it increases for all of the x values. It increases all of our x values. You'll notice in your table as the x's get larger, the y values are also getting larger. So we can tell both in our table and in our graph that this is increasing. We can tell on the graph that the points are going up. We can tell in our table because as the x's get larger, the y values get smaller or larger. Now let's be careful when we answer this next question. The next one wants to know, or for us to write a sentence to describe the domain and the range for the problem situation. Now usually when you're asked for the domain and range, all you do is write down the number. But this time they want me to write a sentence that describes the domain and the range. So let's take a look here. For our domain, which in our case is the number of months, you'll notice that the number of months falls between 18 and 29 months. So that's the sentence we're going to write. The domain is from 18 to 29 months. And you'll know this by looking at the table. Range, on the other hand, the height, you'll notice that the range falls between 76.1 and 83.5. 76.1 to 83.5. And that's our range. Those are the heights. Now, because we did notice a pattern, what they wanted to do is predict the height of a 21.5 month old. So 21 and a half. So if you look at your table, everybody look at your table. If I want to know the height of a 21 and a half month old baby, could we do that? Yes. What would you expect that to be? Look at your table. 78.5. Why would you say 78.5? What's that? The graph. Okay, so you can look at the graph. What's that? Well, but that's for 21.
Oh.
We're looking at 21.5, 21 and a half. So, if you look at the table, and you look between 21 months and 22 months, what we're given there is 78.2 and 78.8. So what's the best thing we can find between 72.2 and 78.8? About 78.5, roughly around there. Okay. So, for a 21.5 month old baby, we can expect the height to be somewhere around 78.5. And you can tell this both in the graph and by looking at the table. All right, the next question. Could you predict the height of a 21-year-old adult? Explain your reason. Could we predict the height of someone that's going to be 21 years old? What do you think?
No.
This is kind of a trick question. Yes and no. If we were to predict the 21-year-old height, what would you guess that would be? If we look at your table and look at your graph. We continue this pattern. 21 years old. Could we figure that out? Sure we could. In this particular case, guys, if we actually did that, what we would find is a 21-year-old would be approximately 7.5 feet tall. What? 21 years old and 7.5 feet tall. You know any 21-year-olds that are 7.5 feet tall?
No.
Probably not, right? So what's wrong here? If we follow this pattern, this is what we're expecting. But what's wrong with that logic there, guys? What's happening as you're getting older? You're getting taller, but what's going to happen eventually? You stop growing, right? You don't shrink or anything, but you do stop growing. Okay, so this pattern that we have here is only going to go on for so long, and eventually it's going to stop. You're not going to be growing anymore. For most of you guys, you're pretty much at your set height. You may grow a little bit more, but you're not going to grow much more than what you are here. Okay? So this is, like I said, a little tricky question here. Yes, we can tell. There is a pattern here. We can predict. And if we do predict, we're looking at approximately 7.5 feet tall. But of course, this would be unrealistic. Okay? So we can only get a realistic prediction within the range that we're working. So within that 18 to 29 months, we can make a pretty good prediction. But if we go all the way to 21 years, our prediction is probably not going to be very good. All right, so that wraps up the review. What you're going to do now for me is you're going to go back, and what I need you to do is finish up all the odd numbers for me.